Not yet. Are we getting audio? Yes, yes, yes. It's always the scariest part, right? Do you see the slides? Do you hear me? So hello, I'm Hannes. Um, I'm gonna tell you a little bit. Um, I love Denmark. Always have. I lived here a year after college, which is quite a while ago, 2005. I also met my fiance here, like a long time ago. We have 3 kids now. That's why we gave them Danish names. So there's that. So you came to a talk with a clickbait title. I'm just going to remind you what clickbait is, right? It's just a phrase to make you click on a particular link to lure you into a site where the content is probably questionable, right? So, yeah, nothing in this talk is going to be super shocking. It may be a waste of time. If you want to walk out, you can do so right now. You have been warned. So, my name is Hannes. As I just explained, my kids have Danish names. And my wife is called Barbara. We met here in Copenhagen last year at DevFest. I ran out of this venue to go and shop for engagement rings. I had a beautiful ring made here downtown by a very nice craftswoman, and she did a beautiful custom ring. And I proposed to my wife, so now we're engaged. And it's all because of Copenhagen, so fantastic. I am the .NET lead coach at a consulting firm called Access in Belgium, which basically means Hannes does whatever he wants. I come from a .NET backend development background. And last year, I made the Dome Train course on Entity Framework because I've always seen teams on 2 sides of the spectrum when using Entity Framework. Either they go from the Entity Framework demos, and what they'll do is they'll create a bunch of model classes and a DB context, and they don't care about what's going on in the database side. Or I see teams working the other way around. They model their classes exactly like they would model a normalized SQL database, but they still map everything one-to-one. But Entity Framework can do so much more than that. And there are so many tweaks that you can do to get more performance out of it or to do more complex mappings. And that kind of triggered me to make this talk. I'm also a line breaker. And for those of you who do not know what that is, we play musical parodies, kind of like what Weird Al Yankovic does, but we have them all in software or IT parody teams. We will be doing that tomorrow night on stage here. Right. Yeah, and I have some community titles. So, what's my plan for today? I think this is quite intimidating. I don't usually do live coding talks, but today is one of them. So, my plan is I'm going to present. I'm going to present you 10 things that Entity Framework Core can do, right? I'm just going to run through them conceptually. I'm not actually going to demo them. Then you get to vote. So you can take out your phones and you can vote on which ones you want to see me live demo. And then for the rest of the talk, I'm going to live code through all of the features that you voted for until we run out of time, and then the talk is over. So you will have reached the end. Now the plan is, if you want to take a nap, you better stay awake for the part where, I know this is right after lunch, so you stay awake for the part where I present all the nifty stuff. If you want to take a nap, do that in the live coding part. It's going to be boring anyway, right? So there's no lunch after this, but there's going to be coffee. So I'm going to present, and I'm just going to take them one at a time, and when we get to the end, you get to vote. So value type properties. Often you are building a model, and your model has some nested classes. So one of your properties is another class, and you go a couple of levels deep. And it's a very nice way to model stuff in your domain when you're using classes and using C#. But when you do that in the database, those classes need to go somewhere. So what you can basically do is you can take a bunch of those columns and map them to the properties of your nested class. And the cool thing with value type properties is you can basically extend those with certain behavior. You can reuse the types. It makes modeling a more complex domain so much easier. And you don't necessarily need extra tables to make that work. So you're still selecting from a single table. It's still very fast. You're just making it much more easier to read the code that you're working with. That was feature number 1. Many-to-many relationships is the next. And many-to-many relationships, what we want conceptually is you have 2 entities, and each of them can have many of the other, right? I go to many conferences, and conferences have many speakers. That's a many-to-many relationship, right? If we were to model that in a database, you would have 2 tables with a primary key. And the way to actually make that many-to-many work, because you cannot put a many-to-many relationship in a SQL database, you would have a small join table where you have a foreign key to each and every one of them, and that is your link between the 2. So you can model it like that in code, and that would work, but you can actually just have 2 properties, 2 navigation properties, pointing in the other direction, and that is no problem whatsoever with Entity Framework. In the database, you will still have a link entity, but in the code, you don't have to have it. You can just have many-to-many navigation between your 2 entities. Also, something you sometimes have to solve is hierarchy. You have data that is modeled in a kind of tree structure, right? Every node has a parent, and every parent can have descendants. And one of the ways that I see this modeled quite often is you have a foreign key that points to the primary key of its own table. You're pointing at your own parent. Now, the problem with this is that this is very, very hard to query. Because when you're querying this and you need to get a part of your graph, like all the descendants of a certain node, you're going to be nesting queries and going to have repeat round trips, and nobody really wants that. So there is a better way of doing this. SQL Server has a feature called hierarchy IDs that allows you to do all those weird querying operations on a tree of data, and you can map that into Entity Framework. And the cool thing is you can just say, hey, give me everything that is below this or this node, and it's just a single round trip to your database, and you're getting all the data that you want to have. You can even get the flexibility of only selecting a certain number of levels deep and stuff like that. Now, who here has used Dapper before? Do you know that you don't need that anymore? We can do raw SQL queries in Entity Framework Core as well since, I think, 7. So basically what we take is we do our SQL query literals and we pump them through our DB context and we execute them on the database and we actually get objects back, just like Dapper does. And the first version of it was super, super slow. Dapper was like way faster. But it has actually gotten really close in EF Core 8. So that's a thing that removes my need for at least having 2 ORMs in a lot of projects. So that's something we got as well. Support for JSON columns. A lot of modern database engines have JSON support for their columns, meaning that you just have a column that has a bunch of JSON data in it. So same example, you have some nested stuff in your model classes in your code. Well, you could just take that and put it into a single field where it's just a JSON graph. And given that these database engines have support for these JSON columns, is you can index a couple of levels deep into the JSON if that's what you please. It makes it so much easier if you have data that moves around in shape a little bit. You can easily dump that into a JSON column and use that through Entity Framework as well. Batch size. I'm not sure if you are aware of this, but a DB context is a unit of work pattern. So as long as you're doing stuff and you're adding objects and removing them and editing them and all that sort of stuff, until you hit save changes, it just queues up the work to be done. So you get a list of queries that need to be executed when you hit save changes. And actually, when you send stuff to a database engine, your round trips actually matter. So if you have 200 commands to be executing, if you do 200 round trips, you're always paying for that database latency. And you don't have to do that because a SQL text can be multiple statements. You can put 300 statements under each other and just send them as one. I think in SQL Server, the limit to that is something around 65 kilobytes. I'm not really sure, but the number is in that region. So what you could basically do is you could take blocks of statements and have less round trips. And you have full control over the batch size. Actually, Entity Framework does this by default. So it already by default queues up a bunch of statements and sends them to the database and back. So exercising control of that is a very, very good way of gaining a lot of performance when you're often executing big workloads in one chunk on one DB context. Now, something that we all do in code, but we're maybe not aware of that we can do that as nicely in a database as well, is inheritance. We basically have inheritance in our classes quite a lot. So if we have a parent class with 2 child classes, there's actually 3 ways that you can model this on the database side. So the first way of doing it is just dumping everything into a single table. This is a default behavior for Entity Framework as well. So you get all of the fields for your parent class and then all of the fields for your child classes, all of the extending fields. And at the end, you will probably need a column that tells you what type of record this is. That's going to be your discriminator. It's going to tell you what is in this row. What should Entity Framework deserialize this at? That's called table per hierarchy, but there's 2 other ways of actually modeling this in a database. So the one that feels most natural to most developers is something that maps the way that you do it in code. So you have a table per type. We basically have a table for our parent entity and 2 tables for our 2 child entities. And those will get primary keys that are also foreign keys, and they point at the parent entity. That way, there can be no conflicts in primary keys and foreign keys. And depending on where you find your records, Entity Framework knows how to deserialize this. Now, the disadvantage of this is that you are doing joins across all of the tables in your inheritance hierarchy, and that may become very slow if there are a lot of classes, right? And then there's a last way of doing it. And that's basically having, the other one is called table per type, by the way. And the last way of doing it is basically we have 3 tables, but we repeat the fields of the parent entity in the child tables, meaning that we don't need to get a join going if we just want to select one certain type of that inheritance hierarchy. We can pull out that table specifically. It makes it a lot easier to do. You do need to do unions to get all your records, but typically those are a little bit more performant than doing a bunch of joins. And that's called table per concrete class. Now, the tricky thing about this is that you need one sequence that actually handles the primary key generation across all of your tables, because Entity Framework cannot deal with duplicates in the same entity, and it's going to treat parent as an entity that it knows about, so you cannot have duplicate primary keys. The latest versions of Entity Framework actually do that by default as soon as you map table per concrete class. Until recently, Entity Framework Core could only do the hierarchy part, like the top right one. Since 7 and 8, we've actually gotten all of these. Entity Framework 6 could do all of these like years ago, but in Core, we've recently gotten them. And then something really cool, double databases. Like, we already have a way to distribute one entity set across multiple tables. Now it's going to be we're going to be able to actually talk to multiple databases from the same DB context. It's a feature that's coming in EF Core 9. So basically what we can do is we can take one DB set and put it in one database, and the other DB sets we put in another database. That's going to be totally possible to do. Now, this is Microsoft's idea of what polyglot persistence can be. They will actually even add support for different database engines across those different databases that we're talking to. You can query and join across these different databases as well. Be aware that it has a performance hit because you're doing that in memory. Logical deletes. Logical deletes is not a feature of Entity Framework, but it's something that you can really easily whip up using a couple of features of EF Core. So the idea is when we delete a record, we don't want it to be gone from our database. We just want to take that deleted flag and set that to true, and then no longer see that record, but still have the data in our database. So you're going to need a couple of features to whip this up. You're going to need shadow properties to hide that deleted flag, but still have it accessible so you can code against it. Global query filters are going to filter out the deleted records so that you don't see them when you're coding against the data. You're going to intercept the save changes so that you're not actually deleting the record, but you're setting the shadow property. And obviously, you're going to have to meddle with the change tracker to get this done. But it doesn't really require a lot of code. It's very easy to get it done. And then you can have logical deletes. But when you're coding against it, you just call the delete on your DB set, which is way nicer than setting the deleted flag whenever in a repository you're seeing that you want to delete something. Compiled queries is something that wins a lot of time when you're building APIs. So basically what happens when we query something in EF Core, you have two things that go into a query. You have the query itself, which you usually write in LINQ, and then you have the parameters to that query, right? And that basically gives us a LINQ expression tree. And that LINQ expression tree gets parsed, and it gets converted into a SQL query, and that SQL query gets executed on the database engine. Results that come back are materialized into objects, and so on. Now, in scenarios where you have a high load API, you're gonna do that LINQ expression tree parsing for every call. And that's typically something you don't want, because usually the only thing that changes is the parameter or the keys that you're passing into the query. The query is gonna be the same. So there's actually an option with Entity Framework to do that pre-compilation part only once, and then keep reusing that, and effectively it will behave like a parameterized SQL query, SQL command that you're re-executing every time, which makes it so much faster for high-load APIs. And then Entity Framework, and I always love this part, Entity Framework doesn't have to have a DB set for anything you talk to it yet. So a DB context actually functions all by itself. As soon as it has a database connection, it can do all of its work. And you can tell it about the entities that you want it to know about. Because it doesn't need that info at compile time, it needs it at runtime. It also gives us the feeling as developers that Entity Framework is sometimes slow. Because what do we do as developers is we code, and then we run F5, and we hit that initialization of that first DB context. It's always slow, a couple of 100 milliseconds you're losing that, right? That's when Entity Framework is building its mental model. It needs to know about what your classes look like, your code model. It needs to look what your tables look like, your database model. It needs to know how to map between the two, right? That happens when you start a process and the first DB context of a certain type that you hit, that initialization happens. That's also the moment where you can feed it new intel. So if you tell Entity Framework in the onModel creating, you tell it about a bunch of types that it doesn't have entity sets for, that's totally fine. It can deal with all of those as well, which effectively makes it possible to have a DB context that learns about all of the types it needs to know about at runtime, which allows for some pretty cool hacks. And obviously, you can still, if you feed it all this data, it's going to derive its mental model. It's going to derive what the database looks like, and it's going to be exactly the same as you would have done with normal DB sets. But that means you can save this data, you can query that data, you can do anything with it that you would please. You're just not going to have a DB set. Totally possible. So, those were my 10 features. Have you counted? No? Okay. We're going to vote now, but there's a little twist. See, I've presented 11 features. One of these was fake news, not real, not happening. The thing is, we're in Denmark. Beer here, as a Belgian, like extremely expensive, like for our taste, right? You have gotten good at making beers though, like Mikkeller, so nice. But very expensive. So if you vote wrong, and I make it with my live coding all the way down to the fake one, that means that you guys owe me a beer, okay? I will tell you what the fake one is at the end of the talk. This is my way of saying, yeah, you're not getting your nap, right? So if you scan the QR code, you can vote on the feature. You can just drag in the stuff that you want to see. This should start moving as soon as you do something. And I have demos prepared for the 10 real ones. So we will do as many as we have time for. And we still have 40 minutes, so that's quite a few demos. Compiled queries, nice. Y'all vote it? Kind of vote it? Yeah? Okay, compiled queries, JSON columns, hierarchical IDs. Okay, we need to make our way at least to that one. Oh, that just popped up. Good. No, back down. Come on. No, it's not. That's actually a real one. But I love it because it solves a particular problem really well. And as long as you don't know that that solution exists, you're going to always be struggling with it. So I love that thing. Okay, you can still, 61 people voted, so I'm guessing that this is going to be pretty much our ranking. So we are going to start coding. The fake one I'll reveal at the end. Right. So hop over into Visual Studio, and I'm going to cheat, and you see my screen. Okay, that's perfect. What I don't see is your votes, but here we go. Compiled queries. Okay, cool. So compiled queries. Let's take a look. That is demo here number 9. Okay, cool. So how I have this set up, just so that it's going to be easy for us to demo, I just have a console application, and I have a function that just recreates the database. It just drops the whole thing. I do ensure deleted, ensure created. It just drops the whole schema and recreates them. It allows us to iterate really quickly. So when I do stuff in code, we can quickly open our SQL Server Management and take a look what has happened in the database side. Right. So compiled queries, and actually in order to do that, what I have here is I have a bunch of records that have been added, like a bunch of movies that have been released in 2023. So those movies will get created in the database, and then it allows me to query them. So what is going to hurt is if we want to parse a query. So I should have a query ready here that's already doing something. No? This is the wrong demo, isn't it? Compiled queries? No. Okay. Oh yeah, this is the save changes. So, this is super weird. This should have more code in it. Did I fuck up? Okay, let's just query this very quickly. So for movies, and I'm gonna, if I take these movies and I query anything from them, parsing the link, like if we have a where clause, anything like that, and I want to query it on the release date. Let's say that for some reason is hurting our performance, right? Is bigger. It should be released after December 2023, right? New. Whoa. Date only. Date only dot. I can just do new, right? That query should have been there doesn't matter. So let's say that we are having performance issues with this. So right. So this is hurting our performance because we're doing it over and over and over again, right? How we are going to deal with this is we can basically make this into a function. And my cheat sheet is there, okay. And if I want to make a function, I'm going to use ef.compiledQuery. So what I'm going to use basically is, instead of this function, I'm actually going to pre-compile this query. So I'm just going to create a variable for the compiled query, private read only. Only going to create my compiled query once. It's actually suggesting that here, very fun. Let's use this where clause, the one that I just told you about. So what this compiled query does is, if we have this query, we basically pass in a couple of parameters. Actually, I'm gonna need the one from my demo. So we can pass in that date only. So we pass in the type of DB context that we want to run our query against. Then we pass in the types of parameters that we want our compiled query to have. In this case, it's a date only. And then we specify what kind of return type we want from our compiled query. So those are our interesting movies. And what we use is, we use ef.compileQuery, and that allows us to take that demo context, and of course we are going to take our date only start date, and that's something that we're going to pass into our compiled query, and that start date is something we can use here as a variable, right? There we go. And what am I missing here? Probably some kind of brace or bracket. I'm guessing around bracket there. That ends my compiled query. Why is it complaining? Excuse me? Yeah, it's confined. Wait, it's. I'm getting a iQueryable of movie back. That is enumerable of movie? Probably that. That solves it. Okay, so we're getting a bunch of movies back. Now this compiles the query. So what this does is, it takes this link, that is the same link that I have written up here, but now with a parameter, right? It takes that link and it parses it once when we create the compiled query. And after that, it just behaves like a SQL command that we can iterate and iterate and iterate over on different DB contexts, and we can do that and pass in new parameters. So what I could do here is, instead of doing this, I can just take my compiled query. So I'm going to take my interesting movies, and I can just execute that. So I can invoke that on my DB context, in this case my context, and I can pass it in my parameter that I care about, which is this one. And we can execute that as often as we want, and what we're actually getting back is the movies that we're interested in. So we do this for every API that basically gets a high load, and we do that over and over and over again. And this is no longer awaitable. So that is a synchronous call now. So that's basically how we can take these and get something more performant out of them, where we don't have to basically do all the link parsing for every subsequent query. So it's not really hard to do, but you have to be mindful, and you have to explicitly make a compiled query object so that the link parsing happens up front, and so that you are reusing this. So this should now work. I should be getting all my movies back with a bit of luck. hitting our breakpoint there. Whoa. Oh, I'm having the wrong startup project. I was worried. There we go. That should solve that. And we should hit our breakpoint. It's creating those movies first. That's fun. Where were we? Oh, I did not succeed in setting that breakpoint. Yeah, that's never gonna work. That's never gonna work. Try again. Wow, the first demo that fails. See, this is why I don't do live demos. Somebody gave me the wise advice once. If the demo works, it could have been a video. And if the demo doesn't work, it should have been a video, right? He was the guy who did the keynote this morning. So, yeah, there's that. But I do have a couple of movies in here. We do have a results view. So my query definitely worked. Do we have anything in there? There is data. Yeah. So we can print them out, but that's how you do your compiled queries, like easy as that. Right? Any questions on this? Yes. That's a good question. I'm not sure if there is an async overload. So, what? In this query? Oh, that will probably, yeah. So that could work. Dot toList toList async. Can we do that? Yeah, there is one. This I should have kept that one, right? toList async. Then my return type should change to. It's not an IEnumerable movie, but it's a task. Oh, come on. See, that happens. Task list movie. I'm gonna. Oh, 2-array async. Okay, then it's an array of movie. There we go. And then we need one more of those in there, right? Wait. It's not that array. Wait, I'm just. There is toList async. What am I doing wrong here? You're spotting this, right? JS type. No, never ever. Compile async. Compile query. Oh, yeah. Thank you so much. Right. So that's the other way of doing it. I'm not sure if this will even run, but let's try that after the talk, okay? But that would probably, now I would be able to do a wait here, right? Yeah. Not sure if that works. We'll try it after the talk. Is that okay? You had the question? Yeah, we'll see that after the talk. Okay, next one you had. Let's hopefully get one where all the code is there so I can be a little bit less stressed. Hierarchy IDs. Okay, that's cool. It's the one I always really want to do. So, the thing is, what you need for this is you need a package to add the support for this. So, hierarchy IDs, what we have here, I'm going to set that as my startup project. There is an extra package I included, which is the Entity Framework Core SQL Server Hierarchy ID, right? It's just to enable support for this. And what that enables us in code is if we take the entire Hobbit family, all of the halflings, you can basically model their position in the graph. These are the ones, by the way. So you have Balbo, who is like the arch parent of the entire family, and he has his children and so on and so on. So these are all the halflings in the family, and you can basically define a node by its position in that tree. So Polo is slash tree slash 3 slash 2, right? Positional in a hierarchy. Now you can basically use that as an extra key on an entity when you save something to a database. So what we have here is I've already prepared these hierarchy IDs because that package enables us to do that, and we parse those and we populate that tree in our database so that we enable it for querying. Now there is one thing that we do have to do. It's something that we have to enable on the DB context as well. It's not something that is going to be there by default. So when we are doing our options builder, what we are doing here is we should basically add the hierarchy ID. So on the options builder, you can do this in your on configuring as well. You can do use hierarchy ID. And of course, that is not doing what I wanted to do. Oh, actually, it's not in the options. It's in the use. It's something we extend on the SQL server. So after we pass in our connection string, it's a SQL Server options thing. So it's not something you can do with other databases. So option, no, not the options builder. .use hierarchy ID, yay. And that just enables that functionality. And that allows us to create a model class that has a hierarchy ID in it. So what that looks like is all we do is we create an extra property of type hierarchy ID. And basically, Entity Framework already knows that this is something that we're going to be able to query just like that. So when we run this code, it should already populate our database with that hierarchical data. I'm not really querying it yet, I'm just saving it. I'm just going to run it for once so we can take a look in the database what this has actually done to our database schema. So that was demo number 3. Is that too small for you to read? Probably is, right? Do we UI scale the whole thing? Is that too risky? I'm going to assume, what could possibly go wrong, right? There we go. Is that a little bit better? So what we've gotten here is we've got our halflings table, and the column that we're getting here is actually of type hierarchy ID. So that's actually a SQL Server feature that we're using. And the data that we're getting in there, you can basically take a look and you see that it's binary data. And that binary data becomes longer and longer and longer depending on which node we are in, right? And that's basically our tree data. But this allows for some pretty cool things. So the way that you can now query this, and I'm actually going to open a profiler so you can see what's going on with that database. I'm quickly going to open that. That's my local DB instance. I only want to see RPC completed and batch completed, right? There we go. So that should show our queries when we start doing things with this in Link. And the fun thing here is when we have that database created, these queries, now we are querying all of the halflings. So we have run this before. You're seeing everybody, right? You see everybody that's in the database, and it comes out like that. Now the fun stuff here is we can query that in completely unexpected ways that would be very hard to do when you're doing a self-referencing foreign key. So the way that this works is you can do a path from patriarch or path from so we can take our halfling and we can basically say my path from patriarch is descendant of, and I'm going to create, now that I've scaled everything, this becomes a problem. And Posco is one of our nodes, right? And now I'm just going to get all of the halflings that descend from our POSCO, and that will include the parent as well. So when we run this, and now of course my UI looks all messed up. When we run this, I should only get the descendants in that tree that are here underneath POSCO, right? POSCO is right here, so I should only get POSCO and like his 3 children and his grandchild, right? And that's exactly what we get. We get those 5 nodes. Now the cool thing is, like in terms of round trips, that is just a single query. So the way that that has been queried is basically this, and I'm not sure, can we enlarge that? So what you see here is it uses a SQL Server function is descendant of. So it's actually leveraging the SQL Server functionality to let you have nice hierarchy IDs in your code as well, and you don't have to do many round trips. So there is descendant of. You can also flip that around, obviously, where we can say like, okay, I just want to get all of the parents. So if we just want to flip that around, you get the path up from your certain node. So you can basically, instead of doing this, you do POSCO, and path from patriarch here, well, that's a hierarchy ID. What's going wrong there? H. POSCO is descendant. Oh yeah, no. Yeah, we don't need that path anymore. POSCO already is a hierarchy ID, and then we need to do h dot path from patriarch. So the path from patriarch is just my property on my model, right? So now it's the other way around, and we will get from POSCO all the nodes up, right? That will work in the other way, and also that leverages the functionality of SQL Server again. Those are the type of queries that would be very hard to do. It also allows you to go to certain levels, so you can play around with the levels. So the cool thing is, if we just, instead of doing this, I would say, hey, h dot path from patriarch dot we get the get level on that. We can basically say I only want the ones in generation 3. Wait, get level equals 3, obviously. That will work as well, and that will also execute on the database instead of in code. But then you get all the ones that have the same length of ID, right? So wait for it to execute for a second. There we go. So that is actually just like the one slice in our here in our generation, right? And of course you can say I'm gonna do descendant of and then include the level as well, and you can mix these things together. It's super convenient when you're working with tree structured data, right? The only problem that I've run into is any framework in its current version gets super confused if you try to make your hierarchy also your primary key. That is like something that throws a bunch of exceptions. So you should have an artificial primary key and then put your hierarchy ID next to it, right? That's the only stuff that I've run into with this, but it also solves some nice problems along the way. We have time, so let's take a look at the next one. Anybody have questions about this? Yes? Can I? Wait. Wait, I'm sorry. Yes? Oh, only for the leaves? I'm not sure what you mean. You can query for any position. Oh, so that you don't get the parent? Yeah. Yeah. So the way that you would do that, I think what you're trying to say is if I say here my path from patriarch is descendant of, and you get our postcode in there, that includes the parent node as well, right? And you only want to see the ones that are below it. Is that what you're trying to say? Yeah. So you only want to see the leaves underneath this. Then we can just go h.bat from patriarch dot get level is higher than than postcode.get level, right? So this one should not include postcode anymore. So you have to combine those functions, but that takes away, because now we only get generations below it. And if you combine those, that solves the problem. At least I'm confident that this will work. Yay, great. Okay, like one more successful demo, and then I've redeemed the failed one from before, right? JSON columns. We have time for that. That's gonna be fine. So JSON columns. Which one was that? Let's take a look. It's demo number 5. It's also not the fake one, so that's good. There we go. In a JSON column, if we have a model that looks something like this, right? You have a shipment, and a shipment has a shipping label, and our shipping label consists of a shipping address and a carrier and a tracking code, right? And we're nesting a few levels deep. We could obviously model this as different entities, but in a lot of times, like, we are not reusing a shipping label for a different shipment, right? So it makes sense to not make that an entity of its own. It should just be saved with the shipment data. Now, if you would model this as owned entities, right? That was the way until EF Core 6 that you would do this. You could do owned entities. Then they would, behind the scenes, still be treated as proper entities, meaning they would require an ID behind the scenes to actually run. Because that's how Entity Framework works. Everything that is an entity needs, at least behind the scenes, some kind of identifier that it will deal with on those entity objects. So let's take a look at what my code here does. I'm actually saving a new shipment, and that has a UPS shipping label, and it's being sent to our office in Antwerp. I'm trying to save that, so let's quickly run and see what kind of database that we get if we do it with owned types. So if we do this with owned types, the way that would look, demo database 5, there we go. We get a shipment table, and it has a bunch of columns in it, and it has modeled it like this. We put everything in there. But behind the scenes, Entity Framework is still treating this as an entity of its own. And that means that it is listed in the change tracker as an entity, and it's causing overhead as well, while it doesn't have to. So let's take a look as how we can basically put this into JSON instead of having that whole hierarchy that we have in there. So we do JSON. We're basically going to have to tell our model to treat this one differently. The way that works is when we create our demo context, it's actually here in the onModel creating that owns one. That is the stuff that we're basically going to have to change. And we do that. This one for the shipping label, we can basically say for that top one, we can make that own type property navigator. So we do the navigator. And that navigator, that is something that we can build up just to do the things that we wanted to do. Oh, obviously one. And we can do that by just saying toJSON on that. So navigator.toJSON, that will take everything that is underneath our shipping label and convert that to a JSON column. So make that into a JSON column in our database so it doesn't treat it as an entity anymore, but it just has that as JSON coming out. So that's super cool. We can also say the owns one here. That is something that we will move into the navigator expression there. So navigator.owns one, and then we can extend it a couple of levels deep if we want to take all that JSON with it, and that's completely how you get that done. So we move that one in there. There we go. And then we are taking the shipping address with us as well. So by just putting that on a JSON, we will get a completely different view when we take a look at our database. We will get only one column, and that will be of type JSON. So let's refresh here. There we go. It is an mvarchar max now. That should be a JSON column, actually. You can do that with a two-type. What's the SQL Server type for JSON again? Drawing a blank. There's a type for it, right? Using JSON columns. Now, in any case, what's in there is actually our JSON. So let's just quickly query this and take a look at what we have here. And I'm just going to copy it and put that in. Quickly make a new one there. There we go. So we are getting our entire JSON object in here. So we're getting our carrier name, our tracking code, our shipping address, and then we go a level deeper, right? And all of it is in there. And this is super useful when you have objects that have missing properties or that sometimes have a different shape, have a lot of inheritance in it. You can easily serialize that into a JSON column, makes it so much easier to handle. It also makes sure that when this mutates, you don't always have to recreate new columns for the stuff that you're changing. If you add something underneath your JSON property, that will just work without the database migration. Now, I'm not saying that every table should just be an ID and a JSON column. There are other database types that you should be using if you do that, like use a document database if that's what you want to do, right? Like DynamoDB, right? 51. We can do one more, right? Raw SQL queries. Okay, that's actually a quite easy one to do. But it's also not the fake one. We are getting Dapper support in Dapper-like support in Entity Framework. So that is demo number 4. Last one. Hope that works as well. So what we're getting here is if I have this query that I want to execute against a database that already exists, and the scenarios where you would do this, I used to use Dapper and Entity Framework side by side because Entity Framework was very slow in certain scenarios. And then if you would know which query to write, you could be way faster with Dapper. Dapper also had less overhead. Now, Entity Framework Core has gotten really good in its overhead. So it's gotten way faster. But sometimes there are queries that are very, very hard to express when you're writing LINQ that would be easy to express when you're writing SQL. And that's the kind of scenarios where I still find myself using functionality like that. Now, the cool thing is, if you do this in a formatable string, we can basically use this on our demo context to query some data. So I'm first going to make that my startup project. There we go. And if I want to get those distributors out there, because what's in this database, I just put a bunch of movies in there. So it's the same movies that we got in that other data, in that other demo. If we want to query those on the distributor and a sum of the gross revenue, let's assume that that's something that is very hard to express in LINQ, right? So how we do that is, if I want to get all of my distributors out there, what we can just do is await on our context dot. No, not distributors. We're not going to do that. And then we'll have to go to the database object of our DB context. That is where we can run those queries. And then you just use the SQL query. And that's a generic method that you can pass your result type into. So I made a type for that, distributor revenue. Distributor revenue is just a simple name and total revenue, right? That's going to come back. If we want to get that back and we pass this query in there, oh, no. What did I do? Okay, if we pass that query in there, that's the one that we should be running. There we go. And we can just do toList async on that, and then we are getting our results back. And of course, I forgot to type when I'm toList async. And what? Of course, a dot. Yes, thank you. Okay, so now we got all of our distributors. We can for each over those. So let's just remove the quotes and let's go. And of course, I mistyped this, so there's that. So this just gets executed into the database as is. Now, this may not work. And the reason that this may not work, I think that this is going to throw an exception, so hold on for a second. Yes, it's there. The required column name was not present. And just like Dapper, it uses conventions to map between your results and your output models. So when we take this, we have our distributor that should be aliased as name, and our gross revenue should be aliased as total revenue, because those are the where did I put that? I did show that, right? So those are the property names that we have here, name and total revenue. We should reuse those as our result column names, and then everything should be peachy, right? Now, the cool thing about this is this is just the start. And this is where this gets better than what we can do with Dapper. So let's first take a look. Oh, is that still throwing exceptions? No, that should work now. Oh, it's recreating database, so let's wait for a second, make sure that this works before I do anything else. There we go. So we're getting all of these production houses, and we're getting their revenue from their movies. Okay, cool. Now, because this is Entity Framework, this is actually an iQueryable. So we can start building onto this using regular link. So let's say that I want to order that query or put a where clause on it. I don't have to basically modify my base query every time. I can just tack on link to this. So if I do here, if I do an order by descending, and then I can just use my revenue class that I'm using, revenue, total revenue, which is then strongly typed and the result of my input query. All of that just tacks on to each other. So that's the cool bit of doing this, and that's something that like Dapper has trouble doing, because this will actually get executed in the database like this. So I'm gonna let this run, but we're gonna take a look at what the query is that was executed. So now I have the one at the top. Walt Disney obviously made the most money. No surprise there. The query that was executed basically has our order by in it. So it takes our base query. This is basically, can you read this? Yeah. So that's the base query that we wrote, and then it just wraps around it with a select from, and it adds our order by on top of that. So even the link that we tack on to this literal query is something that Entity Framework is able to deal with and put into one database round trip, right? And I think this makes this cooler than what Dapper can do. And I guess that's out of time. Anybody have any questions? What's the fake one? You forgot? Come on. What's the fake one? You got to guess? What? The batch size. No, that's real. The batch size is super real. Double databases. I mean, let's take a look. And go back to the slides for a second. Yes. Now, of course, double databases would never work. How are you going to deal with transactions across multiple database engines? We don't want to get back to an era where we're doing distributed transaction coordinators. Whoever had to deal with those? Who has said, you still have trauma? Yeah, right. So we never want to go back there. This is not a real feature. We're not going to be able to talk to two databases from one DB context. So don't expect this feature to come. All of the rest of them were real. So you can easily look them up. I have a whole course out on Dome Train as well. But all of the documentation is on the Entity Framework documentation page. So you can look all of them up by yourself if you want. So that's it for now. I'm going to release you and let you get coffee. I hope you will forgive me the first demo that was a little bit messy. Just remember, Entity Framework Core is awesome. It can do a lot more than you would think at first glance. That's my Twitter handle if you want to discuss this anymore. I have been doing a joke for years where I would give people my ICQ number. And the previous conference, NDC Oslo, where I gave this talk, was the last time that I could actually use that, because ICQ has been turned off, and it makes me sad. So it's no longer a thing. So no ICQ number, but you can hit me up on Twitter if you want to talk about this anymore.